Okay, welcome to this video lecture. I am Dr.B.M.Shameem, Assistant Professor of Department of Naval Architecture and Offshore Engineering at Amet University. So, today we are going to see the lecture topic basic concepts in hydrodynamics. So, basically if you see, this topic is a very basic topic which is important for an naval architect or for an ocean engineer, as well as whoever going to deal with the ocean related or water related studies. So, this course basically developed for the students who is going to pursue naval architecture and offshore engineering, and who is going to design ships or offshore structures. The summary of the course goes like this. So, this is a course which is related to fluid mechanics. So, we know that fluid mechanics, when we discuss about the fluid mechanics, there will be, we can say, the fluid in the static condition and fluid in the moving condition. So, basically we say that the fluid in a static condition, which we will call fluid statics, and we have fluid dynamics when the fluids are in movement, in motion. So, this application basically related to marine related field. So, these two components we will incorporate in a marine environment. Once we incorporate in the marine environment, we will call this subject basically, instead of putting the fluid statics, we know that it is basically hydrostatics, correct. So, hydro means basically water. So, basically it comes to the hydrostatics, and we have the component which is moving, that we call basically hydrodynamics. So, this is the overall summary of the subject, correct. We will deal with some topics related to hydrostatics, correct, very basics on the hydrostatics, which is needed for your ship design and ship analysis and ship studies, and then you have hydrodynamics when the ship is in movement, or other components, other floating structures when it is in moving condition. So, hydrostatics basically deal with the fluid at rest, and hydrodynamics basically deal with the fluid at movement or at motion. So, coming to this subject, so a variety of structures are deployed. We know that a variety of structures are deployed, and different structures are moving in the sea, like heavy structures like a ship, correct, small boats, submarines, submersibles, many marine vehicles are moving in the ships, and there are many structures which has been deployed on the in the sea, correct. For designing, as we know that if I design a component in the land, I should know the property of the land. Similarly, if I am going to design something on my sea or something on water, I should know what is the property of that component. So, basically here we are going to fix, or we are going to design a component which is applicable for ocean, correct. So, I should know what is the characteristics of that marine environment. That is the first component we should learn from this course. Then basically learn the dynamics of the floating structures, correct. The dynamics behind the floating structures, basically it is important for such as the offshore structures and ships, correct, and it is mandatory to understand the fluid behavior, correct, and their effects on the structures. So, at the end, this course would help the students or the viewers to understand the basic concepts involved in hydrodynamics, and later applying this principle in ocean engineering. Overall, you can say you will apply these principles basically for ocean related design and or ocean related analysis. So, content of this subject of this course contains basically, initially we will start with fluids and their properties, then buoyancy and flotation. We will have some concepts behind the buoyancy and flotation. Then we will see some types of flow and their characteristics, basically the kinematics behind the fluid, that basically the fluid here we are going to take as basically water. Then some governing equations which deal with, which basically used in hydrodynamics, which is an application for our ocean related structures. Then flow past submerged bodies, and some worked out examples. So, start with the fluid and their properties. So, what is a fluid? So, fluid is defined as a substance which continuously deforms, correct. That is a component where the fluid and solid get demarcated, correct. The fluid basically it continuously deforms. Now how it will deform? It basically deforms with the application of shearing force. So basically you can define a fluid is a substance which continuously deforms. What do you mean by deform? It changes shapes, correct, or it moves, correct, continuously deforms under the application of a shearing force. Fluid basically of two kinds. It is basically we say of two kinds, that is basically liquid and gas. Now what is a liquid? So liquid is basically defined as a substance which has a definite volume, correct. The substance which has a definite volume we call it as a liquid. For example, water, correct, which means if you take water and you know that if you put the water in a beaker it will take a shape of a beaker, I can say it has a definite volume. Or if you keep it in a 1 liter bottle it will take a shape of 1 liter bottle, correct. Another property is that it will not expand. The water has a property which it can't expand. The expansion property is very very less, correct. Now when you come to the gas, the expansion property of a gas is very high, correct, which means the intermolecular forces or the separation between the individual particles of the gases are very, it is easy. The forces behind the forces, the intermolecular force between the molecules inside the gas is very less. So basically the separation of the individual gas is very easy, but for a liquid, for example in a water, this separation is very difficult. That is one thing how we will demarcate or how we will separate what is in a liquid and what is in a gas. How we will distinguish between this liquid and gas, basically due to the change in density. That is one of the important property of how we will distinct between a liquid and a gas. So the one of the main property is the change in their change in density, rate of change in density. That is the density of the gas changes more readily because we know that the separation is very easy, correct. So the change of density, the density of gas changes more readily than that of a liquid. So if the change of the density of the fluid is negligible or it is nearly zero, correct. If you want to change the density of a fluid which is negligible, that kind of a fluid we basically call as an incompressible fluids, correct. That is called basically we call as an incompressible fluid. So here which fluid is incompressible? That is liquid is incompressible, correct. Liquid is incompressible because the density of the liquid we assume it doesn't change, though there is a small change, but we will say the density will be constant here. So the liquid is generally incompressible and it does not fill a volume by expanding into it, while on the other hand a gas is compressible and expands to fill any volume containing it. For example, if you take an cylinder, gas cylinder, if you take a gas cylinder, you can see you can put the gas, you can compress the gas to much extent, or if you take a tire, you can see you can fill the air to much extent, but if it is not the case with water. That is the difference between a liquid and a gas. So this compressibility of the fluid is defined as the reduction of the volume of the fluid due to the external pressure acting on it. Now let us see some properties, some different properties of these fluids. So first property is basically we call density, or we call basically mass density, or mass density. How it is defined? It is nothing but it is the ratio of mass, to volume. So I can write, it will be denoted by the letter rho. So rho is nothing but it is mass of the fluid by volume of the fluid. What is the unit of the mass? We know that it is kg, it can be gram, it can be ton, so on, if we are taking as a unit. And we have volume of fluid, it can be centimeter cube or meter cube or millimeter cube, whatever it may be. So, unit I can define usually we will use in naval architecture point of view, we will use ton per meter cube, correct, because the size of the ship is large, but basically we will use a ton per meter cube. So, we have units gram per centimeter cube, or we have kg per meter cube, or we have a ton per meter cube. So, density of the water, that is the fresh water, we usually used to take 1 ton per meter cube or 1000 kg per meter cube, and the density of the sea water is usually taken as 1025 kg per meter cube or 1.025 kg ton per meter cube. It is not a constant, it will vary always, because the density will vary depending upon the temperature also. So, that is the mass density. Now, the second property we call weight density or specific weight, weight density or specific weight. So, previously we said it is the mass of the fluid by volume of the fluid, that is called mass density. Here we will basically use weight density, it is nothing but weight of the fluid by the volume of the fluid. Now, what is the weight? It is nothing but mass into acceleration, mass into acceleration due to gravity. So, I can rewrite the expression as mass of the fluid by volume of the fluid, which is nothing but mass density into acceleration due to gravity g. So, what is my weight density? It is nothing but rho into g. If I have a mass density multiply with my acceleration due to gravity, I will get weight density. Now, what is the unit? What is the unit? The unit is nothing but Newton per meter cube. Previously it was ton per meter cube or kg per meter cube. When it comes to weight density, basically the difference is that we know that mass into acceleration is nothing but it is basically Newton. So, I will get Newton per meter cube. The third property is specific volume. Most of the time this is applied to gases. This property is basically used for compressible fluids, that is for basically for gases. It is defined as volume by your mass. The volume per unit mass is defined as specific volume, basically denoted by small v. So, volume of the fluid by mass of the fluid. So, I can write it as 1 by mass of the fluid by volume of the fluid, that is nothing but 1 by rho. Unit is what? It is nothing but a meter cube by kg, that is volume is meter cube by mass it is kg. So, that is what the specific volume. Another property is called specific gravity. So, this is also called as relative density. Specific gravity is also called as relative density. So, defined as the ratio of the density of the substance, correct, to the density of the reference substance, that is called basically specific gravity or relative density. For basically for liquids we will take the reference substance as water, and for gases the reference substance we take basically as an air. It is usually denoted by the letter S for liquids, and it is defined as weight density of the liquid by weight density of water, and it has no unit. So, another important property is called viscosity. We know that if I take milk and honey, correct, definitely we know that there is a change in something is there, some change is there, correct. If I take milk in some flat plate and if I keep it on vertical, we see that the milk will suddenly fall down, but it is not the case with honey. If I take honey in a flat plate and if I keep it vertical, it will move very slowly. Why it happened? It is basically due to the property of viscosity, because the honey here is more viscous, we call it as a more viscous, but the milk when it compared to honey it is less viscous. Now, how will you define viscosity? It is defined as the property of the fluid, it is defined as the property of the fluid, correct, which offers a resistance to the movement of one layer of the fluid over another adjacent layer of the fluid. Basically due to this viscosity, this property of viscosity, there will be a resistance in between these molecules, correct. That property is basically we call as viscosity, and it is also defined as it is a measure of fluid resistance to flow, measure of fluid resistance to flow. Then due to viscosity, as I said, some fluid move very fast, some fluid move very less. As the example I said earlier, milk move fast compared to my honey, correct. So less viscous, the movement will be fast, more viscous, the movement will be less. So basically less viscous more flow, and more viscous it is less flow of the fluid. Now why, what basically happens, what is the chemistry behind this viscosity? It is basically intermolecular forces between these, intermolecular forces are cause of this viscosity. So for instance, as I said in the earlier example, milk, the intermolecular forces are weak, correct, hence it is less viscous, but in the case of honey the intermolecular forces are bigger, so it is very strong. So hence the movement of any body in less viscous medium is easier, correct. If the intermolecular force is less, you can easily walk through, or the body can move fast, it will not give the resistance, correct. For example, if you take in a ship, assume that the ship is moving in water, same ship, assume that there is a tank of honey, you are able to put it in that tank, how it will move? Because the other one, since the intermolecular forces are strong, it will not allow the ship to move. In our other case, you will find it will move. Why? Because the intermolecular force between this causes the viscosity, which will give more resistance to the movement. So that is basically viscosity. Now what will happen to the viscosity when it is heated? That is very important. Very important component of the viscosity is the temperature. When you heat a fluid, the viscosity will change. That is, the once you heat a fluid, once you heat honey, so basically you will find the honey will become less viscous. So whenever you do an experiment, in fluid, one of the important properties is that you should know at what temperature you are going to do that experiment, because it will affect the resistance. It will affect the resistance. If more viscous, we know that it is more force is needed to move. How the resistance can vary, how the viscosity can vary? If the temperature is more, the viscosity can come down, it will affect my force of movement, correct. So that is very important. So basically the viscosity is a factor which is depending upon the temperature. So whenever we do an experiment, we have to say viscosity of the fluid at this temperature, that is important. So when we speak about this viscosity, another one of the main important law is called basically Newton's law of viscosity. It is very important when we deal with any analysis, correct, because it states that the shear stress between the adjacent layers, is proportional to the velocity gradients between the two layers. So what do you mean by gradient? Gradient means any change. So velocity gradient, correct, due to this viscosity property, correct, there may be a change in velocity from one layer to another layer, because another layer is giving a friction to the adjacent layer, correct. So basically it states that the shear stress between the adjacent fluid layers is proportional to the velocity gradients between the two layers. The ratio of the shear stress to rate of strain, the ratio of the shear stress to the rate of strain is basically a constant. This constant we call as a dynamic viscosity. This constant we call dynamic viscosity, or simply the coefficient of viscosity. So which basically it will be defined as tau, which is the applied stress, which is directly proportional to the rate of strain, That is tau is equal to, tau is proportional to dou v by dou y, where dou v by dou y we call as the velocity gradient, which is nothing but it is rate of strain. How it is related? It is directly proportional in the sense with a constant, correct. That is tau is nothing but it is mu, which is called dynamic viscosity, into rate of strain. So basically the Newton's law of viscosity says that the applied stress is equal to rate of strain with a constant, that is called multiplied with a constant, that is called the property of the fluid, that is the dynamic viscosity of the fluid. If you see this diagram, there is a fixed plate and there is a moving plate. So it has been shown what is how the change in velocity happens when the fluid is moving far from the flat or the fixed plate. So we know that the fluid property will be 0, correct. The fluid velocity will be 0 on the surface of the plate. This property is very important, correct. This is called basically a no slip condition, correct, where the fluid velocity will be 0 on the surface of a fixed plate, on the surface of a fixed plate. So if that is the 0 and if it is going away from that fixed plate, you will see the velocity will be increasing. The velocity of the fluid will be increasing, that is 0, then it will be increasing, then it will come to the equal velocity or the free stream velocity on that. So this is what basically how the velocity distribution happens between two plates. Another property is another important property for this is basically fluid pressure, correct. It is defined as force per unit area and its unit is nothing but Newton per meter square, or we will say that is Pascal. So what is pressure force then? So pressure force, if I want to find the pressure force, it is nothing but the pressure, applied pressure into area, applied pressure into area. Another important law which is a basics for hydrodynamics is called Pascal's law. Now what is this Pascal law? It states that the pressure applied at a point in a static fluid which will transmit equally in all directions. Assume that if you take a sponge, dip in a water and apply a point pressure anywhere, you will find that the water is not coming from another point, it will be coming from overall the sponge, correct. So that is basically we call Pascal's law, which defines that the pressure applied at a point in a static fluid transmits equally in all directions. This is a practical example for Pascal's law, correct. You have seen in the service center, car service center, correct. You may have one plunger and you may have one ram. By applying a small force on the plunger, you are able to lift a big weight. How it happens? It is basically due to Pascal's law, correct. How it happens? Basically, if you see here, the area where the pressure act is more. We know that the force is equal to pressure into area. Since the pressure is acting equally throughout, that is what basically Pascal law says. If you apply any force, it will transmit equally. So throughout this area, if the area is more, my force is more, that is force is equal to pressure into area. So if I apply a small force in my plunger, I am able to lift a big weight which is placed on the ram. This is a practical example, practical application of Pascal law. You may find many practical examples which apply this Pascal's law. Another important law is basically called as hydrostatic law. Hydrostatic law, which states that the vertical, that is at any point in a static fluid, the vertical rate of increase of pressure must be equal to the local specific weight of the fluid. Local specific weight of the fluid. Local specific, what is the specific weight? It is nothing but rho into g. Specific weight is nothing but density, weight density. So rho is my mass density into g. Local means what? At that height. So rho g into h, correct. That will give my pressure at that particular point. So if I go deeper in the water, my height h is increasing from the surface. So, if I go deeper and deeper, what will happen? My pressure will increase deeper. So, that is basically rho g into h. H is called basically the pressure head, and you can see here how the pressure is varying, correct, when the depth increases. The pressure will be less at this point, but when the depth increases, the pressure also will keep on increasing. So, this is the first portion of first part of this lecture, correct. That is we discussed basically about fluid and its properties. So, these are the very basic things related to basics of hydrodynamics. We have to learn these things to move forward for the next lectures, and I hope you understood well these basic properties. You may have learned in the schools also these small properties, but in the following lectures we will see the applications and other components, and thank you.